80% of the world's carbon emissions come from fossil fuels, which amounts to 34 billion tons of emissions annually. Now, to solve this issue, we need to invest into renewable energy sources like solar. But solar has its own issues. It takes a lot of land to produce energy, 6 to 8 acres just for 1 megawatt. And only 10% of the sun's energy actually becomes electricity. Aside from that, solar farms cost hundreds of thousands up to millions of dollars to build. Now, this is where space-based solar power was proposed. Space-based solar power is the idea of generating solar power in space and then beaming it down to Earth using electromagnetic radiation, like microwaves or infrared laser beams. The ESA proposed a solution where they had a large solar array in geostationary orbit, which they could beam power down to Earth using microwaves, which would get received by rectangular antennas, also known as rectennas, on Earth's surface, which would convert the microwaves back into usable electricity. Now, the issue with this is that a 1 kilometer large solar array is almost impossible to construct with current technology, and it was just not feasible, not economically viable at all. This is where Aetherflux comes in. It's a very recent startup that has a different approach to solving this. Rather than using one giant satellite and one giant ground station, it wants to use a constellation of smaller satellites that could transmit power to a bunch of smaller ground stations around the world. And they're the ones who pioneered the idea of using infrared laser beams, which have more power density than microwaves. Now, both of these solutions are inefficient. They have a lot of middle steps. The light has to go through solar panels, become electricity, get turned into a laser beam, and then absorbed by the rectenna, which in total makes the whole system 7.4% efficient, which isn't very much. Which is why we want to use solar pumped lasers to cut out all those middle steps. Solar pumped lasers are a type of laser that is generated directly from sunlight. The way it works is you have a luminescent solar concentrator, which is a piece of fluorescent plastic that absorbs sunlight and concentrates it around the edges of the plastic. Now, around the edges would be wrapped, there would be a fiber cable wrapped around, which the photons would be, it would absorb the photons emitted by the plastic, and the atoms in the fiber would get excited. And then when you shoot a photon through the fiber, all those atoms will release their energy, amplifying that photon into a high-power infrared laser beam, which you can reflect and angle towards your receiver on the ground. This could be double the efficiency of the versions that Aetherflux is looking into, up to 14% efficient. And if we scale this up to a satellite constellation with 100 satellites that, which each one collects 20 meters squared of sunlight, we could have satellites that are 3.6 times lighter than what we have today, generating 4,500 kilowatts of energy daily, saving $914 daily. Now, the initial cost to set up this infrastructure would be around $9.3 million, which would break even in 28 years. So this isn't economically viable yet. In order for this to become economically viable in the future, we would need material science research to improve the conversion efficiency of the solar pumped lasers. Along with that, we would want to minimize the satellite weight to reduce the launch cost and look into different types of orbits that could potentially increase the amount of time the satellite spends gathering sunlight. Now, with the solution, solar pumping lasers is a very new technology, and so we think there's a lot of room for improvement, which is why we believe that this could potentially be a game changer in the next 5-10 years. Now, a satellite constellation using solar pumped lasers could provide power to areas with low sun that are underdeveloped and can't build large solar farms, or remote areas like islands and military bases, all while not using any land on Earth and potentially being more efficient than satellites, than solar panels in the near future. Which is why we believe that solar pumped lasers are the road to a green future and reducing carbon emissions.